Welcome, learners. My name once again is Mr. Paul Chilola. Welcome to BLACKSLIDES Online. This is the place where you learn the sciences, namely physics, chemistry, biology, agriculture, and the mathematics. If you are watching this video lesson on our YouTube channel, consider subscribing to the channel so that every time we upload new material there, you are notified on time. So subscribe, hit the notification bell so that every time a new material is uploaded, you are informed. Welcome, learners. We meet now for our Form 3 chemistry lesson, and we are going to dwell on a subtopic called the determination of purity of a substance by boiling point, melting point, and the paper chromatography. So we are going to dwell on this. Kindly watch the lesson up to the end so that you don't miss any point as we discuss. You may wish to take notes where you think it's important to do so. But in case you would like to have a PDF of this lesson, don't hesitate to request for one. Welcome, learners. If you are learning on our main platform, the paid platform, make sure you complete all the assigned work, the assignments, the exercises based on the lessons that we send you. Welcome, learners. So we are going to explore how you can determine the purity of a substance by boiling point, melting point, and paper chromatography. These three together are called criteria for purity. Criteria for purity. There is a set of experiments that can be done to determine whether a substance is pure or is not pure. Welcome, learners. So by the end of this lesson, you should be able to define a pure substance and explain the difference between pure substances and mixtures. You should be able to explain how boiling point is used to determine the purity of a liquid. You should also be able to explain how melting point is used to determine the purity of a solid. You should state the characteristics of a pure and impure substances based on their boiling and melting points. You should be able to describe the principle of paper chromatography and explain how it is used to test the purity of a substance. You should be able to interpret chromatograms to determine whether a substance is pure or a mixture. You should be able to calculate. You should be able to perform simple calculations of retention factors, sometimes also called relative flow values, from chromatographs where required. And lastly, you should be able to apply knowledge of boiling point, melting point, and paper chromatography to solve MSCE examination questions on determining the purity of a substance. So these are the areas of focus, the objectives. So we are going to tackle each objective one after another. Welcome, learners. Welcome to the first objective. Define a pure substance and explain the difference between pure substances and mixtures. For the sake of this lesson, and in the context of chemistry as a subject, we are going to define a pure substance as a material that consists of only one kind of particle. It can be an element or one compound. So such a substance has a fixed composition and constant physical properties, such as definite boiling point and a definite melting point. So we are saying a pure substance is one that consists of only one kind of particle, which can be an element or it can be a compound, and it has a fixed composition and the constant physical properties, such as definite boiling point and the definite melting point. So we meet pure substances every day. Examples include distilled water. Distilled water is pure water because it doesn't contain anything else other than the water molecules in it. Oxygen gas and other gases too, such as nitrogen, hydrogen, all those are pure substances. Copper metal, which does not contain any impurities, is also a pure substance. Sodium chloride, which is the common salt, or the kitchen salt, maybe table salt, all these are examples of pure substances. You can think of others too. On the contrary, mixture is made up of two or more substances that are physically combined but not chemically joined. So the substances in a mixture can be separated by physical methods, which you discussed in junior level. But for today, we are going to dwell on the determination of purity of substances using what are collectively called criteria for purity, namely melting point of a solid, boiling point of a liquid, and the paper chromatography. Welcome, learners. So examples of mixture includes air. Air is a mixture of different gases. You are told that air consists of 78% nitrogen, 20 or 21% oxygen, 0.00434 carbon dioxide, 0.034 carbon dioxide percent, that's the percentage, and the other gases such as the noble gases as well as water vapor contained in air. Salt solution is also a mixture. It contains water and salt. Soil is a mixture of different things: rocky material, sandy material, loamy soil, and others mixed in a certain proportion. It's a mixture. Milk is a mixture of fats and water and other things. So, pure substances and mixtures differ in a number of ways. A pure substance contains only one kind of substance, as we noted already, but a mixture contains two or more substances in it. A pure substance has a fixed composition, while a mixture, the composition of a mixture can change, can vary. In terms of melting or boiling point, a pure substance has a constant melting and boiling point, while a mixture melts and boils over a range of temperatures. A pure substance cannot be separated by physical methods, while mixture can be separated by physical methods such as filtration, evaporation, and chromatography. Welcome, learners, to the platform. Consider subscribing to the channel so that every time we upload new material, you are informed. Invite your friends to join us, whether by subscribing on this channel or by enrolling into our main classroom. Welcome, learners, once again. Why is the purity of a substance such an important aspect of everyday life? Why is purity important? You may be asked in an exam to state the importance of purity of a substance. Scientists and industries need pure substances for a number of reasons, such as medicine. For example, medicine must be pure to be safe. Let's say you are on a treatment and you are prescribed some medicines to take. The medicines must be as pure as possible so that they produce the effect that is desired in your body, which is to heal you. But if the medicines contain other things which may be harmful, can be dangerous to you. So medicines must be pure in order for us to be safe. Chemicals used in laboratories should be pure for accurate results. In chemistry, for example, when you are carrying out an analytical experiment to analyze the composition of something, a certain substance in another, you need to use chemicals that are pure in order to produce results that can be relied upon. Food products should be free from harmful impurities. So the importance of purity, you can give these 3 points as being importance of purity of a substance. All right. So when you complete the lesson, I want you to answer these questions, which is an activity for you. Classify each of the following as pure substance or mixture. So we have distilled water, air, copper, salt solution, oxygen gas, and milk. Just put P for pure, M for mixture, and share with me your responses to this simple exercise or class activity. Welcome, learners. So the key points to remember are that a pure substance contains only one type of substance, while a mixture contains two or more substances which are physically combined. So pure substances have mixed melting points and boiling points, while mixtures, pure substances have fixed melting and boiling points. For example, water. Ice will melt at 0 degrees Celsius. If the ice melts at a temperature other than 0, then it means that the ice is not pure. A liquid pure water would boil at 100 degrees Celsius, but having impurities in it would cause its boiling point either to be greater than or to be less than 100 degrees Celsius. A mixture, on the other hand, has a range of melting and boiling points. So these are the key points to remember about pure substances and mixtures. So, an exam tip for you. In MSCE exams, remember that distilled water is pure water all the time. But tap water is a mixture because it contains dissolved minerals and gases. So this distinction is commonly tested in your MSCE exams. Welcome to objective number 2, which is explaining how boiling point is used to determine the purity of a liquid such as water. How can you tell that the liquid is pure or not pure by using its boiling point? First of all, what is boiling point? So boiling point is simply the temperature at which a liquid changes into a gas throughout the liquid. So the temperature at which a liquid changes into a gas or vapor in case of water is called the boiling point. For example, pure water boils at 100 degrees Celsius at normal temperature and pressure. If the boiling point of water is greater than 100, that is an indicator that there is something dissolved in the water, which is called an impurity. So a pure liquid has a fixed boiling point. That's how you will tell that a given liquid is pure. There's a question I've seen quite often in papers that requires students to say, how can the boiling point of a liquid be used to determine the purity of a substance? The answer to that question is, a pure liquid has a fixed or constant boiling point. That's how you tell that a given liquid is pure. An impure liquid, on the other hand, boils over a range of temperatures because impurities interfere with the boiling process. So how is a pure liquid compared to an impure liquid? So just mentioned that a pure liquid boils at one fixed temperature, like water boils at 100 degrees Celsius. Ethanol boils at 78 degrees Celsius. However, if there are impurities in the liquid, it is going to cause the liquid to boil over a range of temperatures. Examples: pure water boils at 100 degrees Celsius. But salty water boils above 100 degrees Celsius and over a wide range of temperatures. Welcome, learners. In an exam, in your MSCE exams, there is a question that says, describe an experiment that could be done to determine the purity of a substance by boiling point. Usually 10 marks. So here is the format of the answer to such a question. Alright, so in order to describe the experiment, take note that you don't mention the materials separately or independently. Alright, just go straight to what is going to be done. So raise 10 points in order to get the 10 marks. But there are times when the question will also say, use the aid of well-labeled diagram, describe an experiment that could be done to determine the purity of a substance such as water by boiling point. So what you do, you start by saying pour a small amount of the liquid sample into a clean boiling tube or flask. You see, as we describe the experiment, we are mentioning the materials within the description. We have not listed materials separately. This is the format that your answer must have in paper 2, especially questions 1 and 2 of your chemistry exam. Clamp the boiling tube or flask securely on a retort stand. Right, if you don't have a means to clamp the boiling tube, you still have to find a way of holding the boiling tube in securely so that it doesn't fall off. As shown here. So we have a boiling tube into which we have put a sample, which is the liquid to be tested, to be boiled, to be heated until it boils. Okay. So insert a thermometer so that this bulb is immersed in the liquid but does not touch the bottom of the container, as shown here. So the bulb of the thermometer, which is this part, should not touch the bottom of the boiling tube. Heat the liquid gently using a Bunsen burner or hot plate. Observe the liquid carefully as it begins to boil, and then record the temperature at which the liquid starts boiling. Continue heating while observing the thermometer reading. Record the temperature throughout the boiling process to determine whether it remains constant or changes. So you compare the observed boiling point with the non-boiling point of the pure substance if it's available. Alright, so if the boiling point is constant throughout the boiling process, then the substance is pure. If the boiling point changes or occurs over a wide range of temperatures, then the substance is impure. So this is an experiment that can be done to determine the purity of a substance by boiling point. This is the format of the question or the answer that you can give in an exam where you are asked to describe an experiment that can be done to determine the purity of a substance. Remember also not to put numbers like I've done here, just to put bullets. Just put bullets up to the end. If the question says with the aid of a well-labeled diagram, this is the diagram that you need to draw. And remember that when you draw the diagram correctly, before you label the parts, you have 1 mark. By labeling any 3 parts correctly, you have 2 marks. So altogether you have 3 marks for the diagram alone. That means the rest of the points will give you 7 more marks to make it 10. Welcome, learners. So, why do impurities affect the boiling point of a substance? An example of an impurity is salt added to water. So the salt is going to make water impure, and the salt itself is an impurity. So impurities make it more difficult for the liquid particles to escape into the air. As a result, the boiling point increases. So boiling occurs over a wide range of temperatures instead of one fixed temperature because of that. So they can ask you, why do impurities affect the boiling point of water? Because impurities make it more difficult for liquid particles to escape into the air. So the boiling point would end up increasing and the liquid will boil over a wide range of temperatures instead of just one fixed temperature. So in summary, we have said that in order to determine the purity of a liquid by boiling point, you place the liquid in a boiling tube or flask, then you set a thermometer, heat the liquid gently, record the temperatures when boiling begins, observe whether the temperature remains constant or not. So if the temperature remains constant, then the liquid is likely pure. If it changes during boiling, the liquid is impure. Let's look at an example just to appreciate our discussion of determination of purity. A student tested two samples, sample A and sample B. He noted that sample A boiled steadily at 78 degrees Celsius, while sample B boiled between 80 and 83 degrees Celsius. So the conclusion, therefore, drawn from this is that sample A is pure. How do we know that? It's because it boils at a constant temperature of 78 degrees Celsius. Sample B is impure, meaning it has impurities in it. Why? Because it boils over a range of temperatures from 80 to 83, anywhere between. So in summary, we are saying boiling point is used to test the purity of liquids. So pure liquids have a fixed boiling point, and impure liquids boil over a range of temperatures and usually at a higher temperature than the pure substance. For your MSCE exams, in MSCE questions, if a liquid boils at constant temperature, it is considered to be pure. But if it boils over a range of temperatures, then the liquid is impure. Welcome learners, consider subscribing to the channel so that every time we upload new material you are informed. Welcome to objective number 3, which is to explain how melting point is used to determine the purity of a solid. So what is melting point then? We shall define the term melting point as the temperature at which solid changes to liquid. Let's say you are heating ice. The ice is going to change into liquid water at 0 degrees Celsius. Therefore, 0 degrees Celsius is the melting point of ice. So melting point is the temperature at which a solid changes into a liquid. For example, pure ice melts at 0 degrees Celsius at normal atmospheric pressure. So you can tell that a liquid is pure, a solid is pure if its melting point is constant. So a pure solid has a fixed or constant melting point. An impure solid melts over a range of temperatures, usually at a lower temperature than the pure substance. So an impure solid melts over a range of temperatures and usually at a lower temperature than the pure substance. So if the ice contains water, it's not going to melt at a temperature of 0 degrees Celsius. It is going to melt below 0 at a temperature lower than 0. So in terms of melting, For a pure solid will melt at one fixed temperature. But an impure solid will melt over a range of temperatures. A pure solid has a sharp melting point. An impure solid has no sharp melting point. Instead, it melts at over a range of temperatures. A pure substance, for example, pure nathrine, melts at about 80 degrees Celsius, but an impure one will boil at a temperature below 80 and over a range of temperatures. So why do impurities affect the melting point of a substance? So impurities disrupt the orderly arrangement of particles in a solid. As a result, the melting point decreases, and the substance melts over a range of temperatures instead of at one fixed temperature. Explain how or why impurities affect the melting point. So impurities, for example, when you add salt to ice, or if there is salt in ice, the salt is going to disrupt the orderly arrangement of particles in the ice. As a result, the melting point decreases, and the substance would melt over a range of temperatures instead of at one fixed temperature. Welcome learners once again. This is BLACKSLIDES Online, the platform where you learn the sciences, namely physics, chemistry, biology, agriculture, and mathematics. If you have not done so already, consider subscribing to the channel and also hit the notification bell for you to receive notifications every time we upload new material to the platform. If you are learning on our main learning platform, the paid platform, remember to complete the tasks assigned to you. Welcome learners once again. You'll be required to describe an experiment that can be done to determine the purity of a substance, of a solid such as ice, by melting point method. So you'd lay out your work as shown here. You'll begin by saying crush a small sample of ice in 2 small pieces and place it in a clean beaker or test tube. Take note, the crush we are using here is the CRUSCH, not CRA. The CRA is different from this one we are using here. CRA's SH means collision between bodies like cars. It can be head-on collision. That's crash with an A. Crash with a U means breaking things into smaller particles. So in this case, break the sample, the small sample of ice into even smaller pieces and place them in a clean beaker or test tube. We're emphasizing it should be clean. There shouldn't be any impurities in it, otherwise that will affect the melting point of the ice placed in it. Then insert a thermometer so that its bulb is surrounded by the ice but does not touch the bottom of the sides of the container. The setup will look like this. So this is ice, crushed ice, and then we have a beaker. So this is ice. It's crushed. And then we have a thermometer. The use of this thermometer is to measure the temperature at which the ice melts. So clamp the thermometer securely using a retort stand. Allow the ice to warm slowly at a room temperature or heat gently in a water bath. Observe the temperature as the ice begins to melt. Record the temperature at which the ice melts. If it's pure, it's going to boil at 0. If not pure, it's going to melt at a temperature lower than 0. So continue observing the temperature while the ice is melting. Compare the recorded melting temperatures with the non-melting point of pure ice. So ice melts at 0 degrees Celsius at normal pressure, atmospheric pressure. If the temperature remains constant at 0 throughout the melting process, then the ice is pure. If the temperature changes or melting occurs over a range of temperatures, then the ice is impure. Probably there is something dissolved in it. So this, once again, is the layout for your descriptive question that says, with the aid of well-labeled diagram, describe an experiment that could be done to determine the purity of ice using melting point method. Welcome to objective number 4. State the characteristics of pure and impure substances based on boiling and melting points. So a pure substance has a fixed and constant boiling point. For example, water boils at 100 degrees Celsius. Pure water. But if it is impure or something was added to it, it's going to boil over a range of temperatures. In a pure substance, boils at the expected boiling point, like water boils at 100 degrees Celsius. An impure substance boils at a higher temperature than the pure substance. During boiling process for a pure substance, the temperature remains constant while it's boiling, while an impure substance temperature continues to change even when the boiling point has been reached. It's going to increase above the non-boiling point. Welcome to another criterion for purity, another method that can be used to determine if a substance is pure or not pure. This is called paper chromatography. So you should be able to define paper chromatography, state the principle of paper chromatography, describe how paper chromatography is carried out, and explain how paper chromatography is used to determine the purity of a substance. You should also be able to interpret chromatographs and calculate the relative flow value, or sometimes known as retention factor, from given data. So, paper chromatography is a laboratory technique used to separate the different components of a mixture. It is used to test whether a substance is pure or not pure. Examples of substances separated by paper chromatography include ink. In junior level, you might learn that you should have learned that ink contains different pigments mixed in it. You can also analyze food colorings, plant pigments such as chlorophyll and other pigments found in a leaf, dyes, and medicines. So these are the materials that can be, the substances that can be separated using paper chromatography. So what is the principle behind paper chromatography? Paper chromatography works because different substances are dissolved differently in the solvent. In other words, the substances in a substance have different solubilities. The substances are attracted differently to the chromatograph paper. As the solvent moves up the paper, by capillary action, the substances move at different speeds and separate into different spots. So in order to carry out this process, you shall need chromatograph paper, which is simply filter paper, but you cut it into a rectangular shape. You can also use a beaker or any suitable jar, a solvent, which can be water or ethanol, depending on the solubility of the substance. You also need a pencil, capillary tube, and a sample solution, which is in this case the substance to be analyzed. So this is the setup of the experiments that can be done to separate pigments into different colors. So this is just a beaker containing solvent, and this is a filter paper on which a line is drawn. This line is it marks the point where you place the sample. It is called the baseline, which is also pencil line. So you put your sample there and carefully dip this into a solvent. So the solvent will rise up. As it is rising, it's going to dissolve the sample so that the samples will separate out into components at different positions on the paper. So this is the setup of the paper chromatography to analyze the components of food color. There are terms that are used in reference to this. You meet terms like mobile phase and stationary phase. Mobile phase is simply the sample product which rises up through the chromatograph paper. The solvent itself also rises up, thereby dissolving the sample into different pigments. So in this case, the mobile phase is the solvent being used and the substance that is being separated. The immobile phase, in this case, represents the part of the setup which is not moving. So in this case, the chromatograph paper itself is a stationary phase because it doesn't move relative to the substance being analyzed and the solvent. Related to chromatography, we have a term which is called the retention factor, sometimes known as Relative flow value. So, relative flow value or retention factor is used to identify substances, to tell whether it is pure substance or simply to identify it, to get its identity based on some standard substance. So in order to calculate the relative flow value, you take the distance moved by this substance from the baseline divided by the distance traveled by the solvent, again from the baseline. For example, if the spot or the substance moves a distance of 4 centimeters and the solvent moves a distance of 8 centimeters, then the relative flow value is going to be 4 divided by 8, which is 0.5 or half. So the answer is 0.5. Some important points to note is that relative flow values have no units. Here we have 4 centimeters over 8 centimeters. So the centimeters are going to cancel out, leaving the answer without units. Relative flow values range between 0 and 1. So in other words, they cannot be minus, they cannot be greater than 1. And also take note that the distances are measured from the baseline. Welcome learners, this is BLACKSLIDES Online Secondary School, where you learn the sciences. Invite your friends, wherever they may be, so that they can join us and learn from here during this holiday time. Let's appreciate the calculation of the relative flow value or the retention factor by an example. So we have this setup, a chromatogram. This is a paper chromatogram. This is the baseline where the ink is placed here. So clearly the ink is made up of 3 different substances. We have green, red, and blue mixed together to make this black ink. So during chromatography, green moves a distance of 2.5. While red moves a distance of 5 centimeters. And the blue has moved a certain distance, which I have not shown here. And remember that all measurements are done from the baseline, which is here. So you get a ruler, measure this distance, measure these distances, measure this distance is the distance covered or moved by the solvent, 8 centimeters. So relative flow values or retention factors values have no units and are always between 0 and 1, cannot be greater than 1. So in order to calculate the relative flow value, let's just pick 1. Let's suppose that blue moved a distance of 6.5. Using the formula, distance moved by the spot divided by distance traveled by the solvent flange. Alright, so relative flow value of the blue substance, which is this one here, will be 6.5 divided by 8.0, which is 0.01. Take note that the centimeters will cancel out so that the result does not have any units. The red ink has traveled 5 centimeters, so its relative flow value is going to be 5 centimeters divided by 8, which is 0.63. While the green component has moved a distance of 2.5, so its relative flow value is going to be 2.5 centimeters divided by 8.0 centimeters, which is 0.31. Welcome, learners. My name is Mr. Pochilola, your teacher. Consider subscribing to the channel so that every time we upload new material, you get notified. In case of questions, just leave a comment in the comment section, and I shall be glad to come back with a response and clarification where you might miss something. Welcome, learners. You are going to be faced with a question that says, with the aid of well-labeled diagram, describe an experiment that could be done to show or to determine the purity of ink by paper chromatography. So you lay out your work like this in order to get all the 10 marks. So begin by saying draw a pencil line, a pencil baseline 2 centimeters from the bottom of the strip of chromatograph paper. So this distance here is 2 centimeters. Place a small sample spot of ink on the center of the baseline. That's this spot here. Then pour a small amount of solvent into a beaker, ensuring the solvent level is below the baseline. Suspend the paper in the beaker with the lower end touching the solvent and cover the beaker. Allow the solvent to rise up the beaker or paper by capillary action. Remove the paper before the solvent reaches the top and mark the solvent front with a pencil. Leave the chromatogram paper to dry and observe the number of colored spots formed. Then measure the distance traveled by each spot and by the solvent front. Then calculate the relative flow value or the retention factor for each spot using the formula distance traveled by spot divided by distance traveled by the solvent front. And you conclude by saying if only one spot is produced and only one retention factor value is obtained, then ink is pure. If 2 or more spots and the different retention values, factor values obtained, then the ink is a mixture. So that's how you describe such an experiment in an exam. Welcome, learners. So this has been me, your teacher, Mr. Pochilola, wishing you a beautiful day. We meet again later in the day. You pardon us. We have challenges of electricity in this area, so it happens that lessons are either delayed or not taught at all. Wishing you a beautiful afternoon. We meet again later. Bye-bye for now.